everyone, here we are going to continue with the topic understanding quadrilateral, and we'll be doing the third part of this chapter. Here we are going to discuss the various types of parallelogram. Before going for the various type of parallelogram, let's see what is a parallelogram. So the parallelogram is a quadrilateral in which both pair of opposite sides are parallel, and we have few properties of a parallelogram. So the very first one is both pair of opposite sides are parallel and equal. Then diagonals bisect each other and opposite angles are of equal measure. Now the very first type of parallelogram is rectangle, and the properties of the rectangle are all the properties of parallelogram including the diagonals are of equal length and the vertex angle is of 90 degrees. So the properties of the rectangle, all the properties of parallelogram, which are going to include all three, then the diagonals are of equal length and the vertex angle is of 90 degrees. Then the next one is rhombus. In rhombus, again we have all the properties of parallelogram including the diagonals are perpendicular to each other and all the sides are equal. And here we get the properties of rhombus as all the properties of parallelogram, which is going to include all three. Then diagonals are perpendicular to each other and all sides are of equal length. Then the next type of parallelogram is square. In square, we have all the properties of parallelogram, all the properties of rectangle, and all the properties of rhombus. And here we get for square all the properties of parallelogram, rectangle, and rhombus. Now apart from these types of parallelogram, we have few more types of quadrilaterals as trapezium and kite. Now here we have got this figure as a trapezium in which one pair of opposite sides are parallel to each other, and if this side is equals to this one, that particular type of trapezium is given the name of isosceles trapezium if the non-parallel sides are of equal length. And here we have this quadrilateral as a isosceles trapezium in which this non-parallel sides are of equal length. In this figure we have the base angles are of equal length as a property of isosceles trapezium. Then we have a kite. Now this type of quadrilateral is named by a kite. In this one we have this side equals to this one and this side is equals to this one. We have the two obtuse angles are of equal measure. These two angles are of equal measure and this line bisects this one. That is, this side will be equals to this one. Only one of the diagonal is bisected, that is the shorter one, not the longer one. And we are having two obtuse angles are of equal measure. Two adjacent sides are of equal length. Now let's move to exercise 13.3. In question number 1, we have to identify the quadrilateral which have four sides of equal length. So the very first one is square and we have the next one as rhombus. Then in the next one we have four right angles. So we have two again, the rectangle and square. Now in question number 2 we have to explain how a square is a quadrilateral, a parallelogram, rhombus and a rectangle. So a square is a quadrilateral because it has four sides. Then a parallelogram as both pair of opposite sides are parallel. Then a rhombus as all the sides are of equal length. Then a rectangle as all vertex angle is of 90 degree. So square has a property of all quadrilateral, parallelogram, rhombus and rectangle. Now in question number 3 we have to name the quadrilaterals whose diagonals bisects each other. So we have parallelogram, rectangle, rhombus and square. Then the next one is perpendicular bisector of each other. So we have rhombus and square. And here the diagonals are equal. So it is in rectangle and square. Now in question number 4 we have one of the diagonals of a rhombus and its sides are equal. We have to find all the angles of the rhombus. As per question we have the length of diagonal is equals to the length of the sides. Therefore this triangle ABD is having all the sides are of equal length. So we can call this one as a equilateral triangle. And as this is an equilateral triangle, this angle will be of 60 degree. Now here we have been given with BD equals to AB. So in triangle ABD we get AB equals to BD equals to AD. So therefore it is an equilateral triangle. And as this is an equilateral triangle, the angle A will be equals to 60 degree as interior angle of a equilateral triangle. Angle A and B will be having the sum of 180 degree by co-interior angles. And here we get angle A plus B equals to 180 degree by co-interior angles. Now we can place the value of A over here as 60. 60 plus angle B equals to 180 degree. And we get angle B equals to 180 degree minus 60. That is angle B equals to 120 degree. Now this angle C will be equals to angle A as opposite angles, and angle D will be equals to angle B as opposite angles. And here we get angle C equals to angle A by opposite angles of rhombus, we got 60 degree, and angle D equals to angle B as opposite angles of rhombus as 120 degree. Now let's see question number 5. Here we are having a rhombus ABCD in which AC and BD are diagonal, which are meeting at point O. We have been given with X, Y, 6 and 8 as the length of the parts of a diagonal. Now we know the diagonals of a rhombus bisect each other. Therefore, this X will be equals to 8 and Y will be equals to 6. And here we get the value of X as 8 and Y as 6 by the using property of diagonals of rhombus bisects each other. Now we know the diagonals are also perpendicular to each other. Therefore, this triangle AOB will be a right angled triangle. And here we get triangle AOB as right angled triangle as the diagonals of the rhombus are perpendicular to each other. Now we know the value of X, we know the value of Y, so we can use the Pythagoras theorem to get the value of Z. So by Pythagoras theorem we get Z square equals to X square plus Y square, and this Z square will be equals to X square, that is 8 square, and Y square, that is 6 square, that is equals to 64 plus 36, and this will be equals to 100. Now taking square root on both the side, Z will be equals to the root 100, that is Z equals to 10 as answer. Now here in question number 6, we have been given a trapezium ABCD in which AB is parallel to CD. We are also been given with angle B and C, and the ratio of angle A is to D is been given as 5:7. So very first of all, with the help of these two, we can find the value of angle B and C. Now as these both are the parallel lines, so these two will be co-interior angles, and the sum of these two will be equals to 180 degree. And here we get angle B plus angle C equals to 180 degree by co-interior angles. So 3x plus 11 plus 5x minus 31 equals to 180 degree. 3 plus 5 will be 8x, and the sum of these two will be minus 20 equals to 180, and here 8x equals to 180 plus 20, that is equals to 200, and x will be equals to 200 upon 8, so x is 25 degree. Now we can place the value of x over here and here to get the value of B and C. And here we get angle B equals to 3 into 25 plus 11, that is equals to 86 degree, and angle C equals to 5 into 25 minus 31 equals to 94 degree. Now we're going to find the value of A and D with the help of these two. Here we are being given the ratio of these angles as 5:7. So with the help of this, we can take the angles as 5A and 7A. And here we have supposed the angle A as 5A and angle D as 7A. Now as they both are also co-interior angles, so the sum of these two will be 180 degree. Now the value of angle A is 5A and the value of angle D is 7A equals to 180 degree. Now 5A plus 7A is 12A equals to 180 degree, and here we get A equals to 180 upon 12, that is equals to 50 degree. Now we can place the value of A in 5A and 7A to get the value of A and D. And here we get angle A equals to 5 into 15, that is 75, and angle D equals to 7 into 15, that is 105 as answer. That's all for this video. Thank you.